Have you ever wondered if skyscrapers shrink and grow? It sounds strange, but they do. It's not magic, it's science. This phenomenon is called thermal expansion. It's a fundamental principle that affects everything around us, from the tallest buildings to the smallest objects in our homes. Imagine a hot summer day. The sun beats down on a skyscraper, warming it up. As the building absorbs heat, its materials actually expand. This means the skyscraper gets a tiny bit taller. On a cold winter day, the opposite happens. The building cools down and its materials contract, making it a tiny bit shorter. These changes might be small, but they are important. Engineers need to factor in thermal expansion when designing structures. If they don't, bridges could buckle, train tracks could warp, and buildings could crack. Understanding thermal expansion is crucial to building safe and durable structures. This essay will explore the fascinating science of thermal expansion. We'll see how it affects our everyday lives and the world around us. Join me on this journey of discovery. Let's dive into the heart of the matter. How does thermal expansion actually work? The key lies in the movement of molecules. Everything around us is made up of tiny particles called molecules. These molecules are always in motion, vibrating and jostling around. When we heat something up, we are giving those molecules more energy. They start to move faster and bump into each other with greater force. This causes them to spread out, taking up more space. As a result, the object expands. Conversely, when we cool something down, we are taking energy away from the molecules. They slow down and their vibrations become weaker. This allows them to pack closer together, taking up less space. The object contracts. Think of it like a dance floor. When the music is slow, the dancers can stay close together. But as the music speeds up, they need more room to move and groove. Similarly, molecules need more space to jiggle and jive when they are heated up. Thermal expansion can create significant challenges in engineering, especially when dealing with large structures like bridges. Imagine a bridge spanning a wide river. As the temperature changes throughout the day and year, the bridge expands and contracts. This movement could cause the bridge to buckle or even collapse if not properly addressed. Engineers have come up with ingenious solutions to account for thermal expansion. One of the most common is the use of expansion joints. These are gaps built into the bridge structure, often filled with flexible materials. These joints allow the bridge to expand and contract freely without putting stress on the overall structure. Another solution is the use of materials with low coefficients of thermal expansion. The coefficient of thermal expansion is a measure of how much a material expands or contracts for every degree Celsius change in temperature. By choosing materials with low coefficients, engineers can minimize the impact of temperature fluctuations. Thermal expansion isn't just a concern for engineers. It affects many everyday objects and systems. For example, railroad tracks are particularly susceptible to thermal expansion. On hot days, the rails can expand significantly, causing them to buckle and create dangerous conditions for trains. To prevent this, engineers install expansion gaps between sections of rail. These gaps allow the rails to expand and contract without putting stress on the overall track structure. You might have noticed these gaps if you've ever walked along a railroad track. Thermal expansion also affects things like power lines, sidewalks, and even our own homes. Have you ever noticed cracks in concrete sidewalks? These cracks can be caused by the concrete expanding and contracting with temperature changes. One of the most familiar applications of thermal expansion is in thermometers. Traditional mercury or alcohol thermometers rely on the principle of thermal expansion to measure temperature. When the thermometer is heated, the liquid inside expands and rises up the narrow tube. Conversely, when the thermometer is cooled, the liquid contracts and drops down. The scale on the thermometer is calibrated to correspond to specific temperature readings based on the known expansion and contraction properties of the liquid. This simple yet ingenious device allows us to accurately measure temperature, thanks to the power of thermal expansion. Understanding thermal expansion is crucial for designing safe and durable structures. By accounting for the expansion and contraction of materials, engineers can ensure that bridges, buildings, and other structures can withstand the stresses caused by temperature changes. Ignoring thermal expansion can have disastrous consequences. Bridges could buckle, buildings could crack, and machinery could malfunction. In extreme cases, neglecting thermal expansion could even lead to catastrophic failures. By understanding this fundamental principle, we can build a safer and more resilient world. We can design structures that adapt to changing temperatures and withstand the test of time. From the towering skyscrapers that grace our cities to the humble thermometers we use to check our health, thermal expansion is a ubiquitous force that shapes our world. It's a reminder that everything around us is in a constant state of motion, responding to changes in temperature. As we've explored in this essay, understanding thermal expansion is essential for engineers, architects, and anyone involved in designing and building structures. By taking this principle into account, we can create structures that are safe, durable, and resilient to the ever-changing environment. The world of thermal expansion is full of wonder and discovery. I encourage you to continue exploring this fascinating phenomenon. Research different materials and their coefficients of thermal expansion. Learn about the innovative ways engineers are addressing thermal expansion in their designs. The more you learn about thermal expansion, the more you'll appreciate the intricate workings of our world. So, go forth and explore. The universe of knowledge awaits.